Hello everyone, I'm Sang-Gun Kim, a PhD student of Texas A&M University. In this video, I'm going to talk about instruction set architecture of y86-64 processor. And I'll mainly talk about programmer's visible state of this processor. Programmer visible state is a state that programmer can read and write some part of the processor state. We will use this state for testing purpose. So as we saw in the previous video, so we will have two different set of programmer visible state, one from our own y86 processor with logisim, and the other output or visible state from the YIS. And then here we have the visible state on down here, and then we'll talk about one by one and then try to see where these are located in the data path figure on the right hand side. But again, programmer visible state is kind of an output of processor. So like you saw this workflow in the previous video, we have two output, one from our processor design and the other output from YIS. So we will compare these two to check whether your processor executes same program exactly correctly. So first program visible state is program counter, and it holds the address of the instruction currently being executed. And where is this in the data path figure? So let me annotate. It is over here. Okay, so you can see the changes of this program counter register as your program is executed. Next state is a register file, and it is kind of set of registers. And here we have 15 program registers, and it is named with human-friendly name, which we use in assembly code. And here also it has a machine-friendly name, which is just integer numbers, and we will use this for machine code. Okay. But why we have only 15? Why not 16? Because we need 4 bits to encode this 15 registers. Then why not having 16 registers? It is because we wanna have one information which the current instruction does not need to read or write any register here. Then it is easy to decode and execute. So we use the 16th information to indicate the current instruction does not need a register read or write. So that's why we have only 15 program register. And then each of this register has 64-bit long, so which means it can store 8 bytes. And then here we have a special register which is called RSP, and it is used as a stack pointer, and it is used by push, pop, call, and return instruction. Because these 4 instructions will implicitly update RSP value, so we should be careful to use this RSP. If you want to read or write this register for your own program execution, you should be careful because it will be changed by this instruction as well. The next visible state is condition code, and it stores the effect of the most recent arithmetic or logical instructions. So in y86, we have two arithmetic instructions, so add and sub, and two logical instructions, AND and XOR. So if the outcome of these four instructions satisfy a certain condition, then we will set or reset the corresponding bits for that. So here we have three flags or 3 bits. To the first is a 0 flag, and we set this flag if the most recent operation yielded 0. The second flag or second bit is sign flag, and we set this flag if the most recent operation yielded a negative value. And the third bit or third flag is overflow flag, and we set this flag if the most recent operation yielded, last operation caused a truth complement overflow. So we will talk about what I mean by truth complement overflow later. So let's see where these flags are located in the data path. So this is the module here. Is the condition code that stores these 3 bits. So next visible state is memory, and it is conceptually a large array of bytes, and it holds both program and data. So in the data path, you can see 2 memories, one instruction memory down here, and the other one data memory here. So instruction memory holds machine code of your program, and data memory holds program data. And we will set this initial data of instruction memory and data memory by using the logistic memory file we generate using the yo to mem script. And the last visible state is program status, and it indicates the overall state of program execution. And so I noticed that it is not very useful for our the implementation and execution of y86 program. So I'm not going to talk about this in detail. Okay, that's it. So in this video, I talked about programmer visible state as a first part of instruction set architecture. And in the next video, I'll talk about instruction format of y86 and its computations on sequential processor.